Hi everyone, welcome to B1016. My name is Matthew Lockwood and I'm one of the professors here at Fanshawe College who will be working within this lab. So it's really important first and foremost that you show up to the lab with all your proper safety gear, so your boots, your safety glasses, and long pants, and we're ready to work. But not only is it important that we are dressed appropriately for the lab, it's also important that before we turn the equipment on, we know that it's in good working condition. Remember that unlike the manual machines where we will be physically turning handles to adjust our table and our tool up and down, these machines work automatically, and we really want to make sure that everything is in good condition before we get started. So in order to safely turn the machine on, we're going to follow 5 really simple steps. So the very first step that we're going to be following is performing a circle check. And this is done in industry as well as here at Fanshawe College. And really the reason that we're doing that is because there are a lot of students that are going through this lab each week. And we want to make sure that the machine is in proper working condition when our section comes to the lab every time. So circle check, pretty self-explanatory. We're going to be going around the entire outside of the machine as well as looking inside the machine and making sure that everything is in proper working condition. Now right now I'm at the very front of our Cyclone milling machine, and you will see our doors are locked. I cannot open them. So really quick and easy, the first thing I'm going to do is I'm just going to look in the machine and make sure that there's no broken tools, the vise is still in one place, there's nothing like jammed inside the table, and that everything looks good. Not only that, we also have these 2 windows that allow us to look inside the machine. I want to make sure that none of these are broken and there's no dents or dings or anything like that in the tin work of the machine. All that looks good. The next thing I'm going to do is I'm just going to move over to the control panel, and I want to make sure that this isn't cracked, all the buttons and everything are clearly visible, and nothing has been worn away or scratched, and that when we are looking at our control panel, everything is clean and really visible, so we know what each one of these buttons is going to be doing. I'm also going to be looking at my hand wheel, which is normally on the far right hand side of the NC controller, and I'm just going to make sure that the cable that attaches it is also in good working order. It's not frayed or cut, anything like that. The last thing I'm going to look at on the very front of the machine is my coolant level. The nice thing about CNC machines is we no longer have to have a little squirt bottle that we're spraying as we're machining. We can input one simple code, it's an M08, and our pump will automatically turn on to flood our tool with coolant. Our coolant is stored at the very bottom of the machine, and basically it's just a big tank, and when we turn that code on, it pumps coolant up, it splashes onto our tool, and then it falls back down and cycles into our tank. It's just one big loop. We have a sight glass on the very front, and we want to make sure that it is at least half full and our coolant looks like it's in good shape. If our coolant is a little low, no big deal. We'll just fill up a bucket over at the coolant mixing station and we'll pour it into the machine. So judging from the front, everything looks good. And now we're going to move around to the side of the machine. So when we come to the left-hand side of the machine, you're going to notice that we have another side door. And it's really nice because we can open this up by pushing and then rotating this handle. And this door allows us really good visual access into the side of the machine. Here we can see our tool changer as well as our vise, and we get a really good view making sure that, again, there's no damage inside this machine. One really important aspect that I just want to touch on is this handle is not linked to any interlocks, and that means that this door can technically open and close when we are machining. So it's really, really, really important that when we are machining, this door is closed and the handle is down. We don't want to have these doors open when we're machining. When we get to the back of the machine, there's a lot of things that we want to look at. Starting at the very right-hand side, we have our hydraulic cabinet, and on here you'll see we have a screen. We want to make sure that this is clean. This pulls air in and it cools the hydraulic system for the entire machine. Another thing that we want to look at that's really important is our weigh loop. This is our way lube, and one of the really nice things about CNC machining is that we don't have to oil and grease our slides. Every now and again, the machine will automatically pump way lube out onto all of our moving pieces, and that way we know that the machine is being properly lubricated. We want to make sure that this is somewhat full. I would say at least half to a little bit higher. One nice thing about the way lube is if it gets too low, the machine will go into an alarm and it lets us know when it will stop moving. In order to fill this, we just remove this yellow cap and we pour in the proper way lube oil. If it comes to that, please let either myself or Eric Weishus, the technician in the lab, know, and we will fill this for you, or at least show you how we need to fill this. Where this is the way lube and this is clean oil that will be used to lubricate all the sliding components in the machine. Down at the bottom here, you're gonna see that we have this small bucket. This is our tramp oil. And what tramp oil is it is dirty oil that has gone through the machine, it's lubricated all the slides, and it has now rinsed or been wiped off those moving pieces, and it can no longer be used again. So if I rotate this bucket, you're gonna see we have a small amount in the bottom. That's fine. If that starts getting too full, we will dump it into a bulk oil container that is at the back of the one Cyclone milling machine. It's really important that this bucket is below this drain port here, because if this bucket is to the left or to the right, then obviously this will pour on the floor and then we'll have an oil spill, which we will need to clean up. Okay, so now we're going to be looking at the electrical cabinet. These machines draw a lot of voltage. I believe it's 550. And so there is a lot of power that's going through this electrical cabinet at any time. Just like how we have our hydraulic cooler, we also have our electrical cabinet cooler. So basically it pulls cool air in here through fans, and then it blows it out in order to cool all the circuits that are controlling our machine. Really what we want to look for is that there's no arcing marks, so there's never been any electrical fires or any arcing or any damage to the electrical cabinet. Everything looks good. You're also going to notice that we have the main power switches here. It's red. We're going to be using this to turn the machine on after we've completed our full circle check. So finishing off our circle check, really all we have over here is the air line connections. The machines do need compressed air to run for tool changes. This ball valve indicates which direction the air is flowing. So the air is flowing to the machine. It may be in odd cases that this is turned to the right. That means that no air is running through. So it is important that we just make sure that the machine is getting air. Again, you will get an alarm on the NC controller if there is no compressed air or if there's low air pressure to the machine. We also have some of our cabling which connects our computer system so we can load and remove programs from the NC controller. And we also have a door which is very similar to the door on the other side, which again, we can always push and open. It's a little bit more crowded over on this side, but again, if you want to get a good view in and ensure that everything on the inside of the machine is in good working order, you can open this door and take a look in. It is very important. Again, these are glass windows. It is very important that they are not cracked or broken. If you see that these are broken, please let either myself, your practical professor, or Eric Weishus, the lab technician, know so we can get that replaced right away. After we've completed our circle check, our next step is to turn the main power on. This switch is located on the back, and you only need to rotate it a quarter of a turn in a clockwise direction. So after we turn the main power on at the back of the machine, think of this like any other computer. It takes a little bit of time to boot up. So you do have to be patient while the NC controller does all of its self-diagnostics. After it turns on, it's going to come to a main home screen, and then we have access and are able to actually use the controller. So here you can see here, it's now fully loaded up, and we're ready to move on to our very next steps. So when we look at our screen, you're going to see very first we have a big red bar that is going across the center of our screen. Anytime you have a major alarm, it will come up in this big red bar like this. Generally speaking, that is if you have pushed the emergency stop button, or if we have crashed the machine into something and the machine has gone into a servo overload, this bar will come up. We also have smaller red alarm messages up at the top. These are other things that need to happen or other warnings, but they're not as severe. So earlier I discussed like low way lube or low air pressure. Those alarms will be up here. These are our major alarms. So in order to turn off this external emergency activated alarm, our next step is we need to remove the e-stop or turn the e-stop off. We do that by simply rotating this, not even a quarter of a turn, and the e-stop will pop out. We've now deactivated that emergency stop. The next thing we need to do is press our escape button to remove that full alarm. So that would be step 3, is remove your emergency stop or turn off the emergency stop. The reason that this would be on is because when we turn the machine off, we do hit the e-stop, and that activates brakes, which lock all of your axes in place. So moving to our next stop, you'll see that we have 2 more warnings that are being displayed in the top left-hand corner of the screen. And the one says push servo on, and the other says home search not done. The very first thing that we need to do, or our next step, is we need to turn our servos on. Our servos are the electronic motors that rotate. They have encoders on them, and that's how the machine tracks the distance our table has moved. This is what makes us have the ability to work so accurately. So in order to turn our servos on, it's really easy. We have this green button here, and you'll see it says servo in the middle. We just press it. And again, we need to wait a few seconds for the servos to kind of warm up and turn on, and the NC controller to recognize that there is power going to them. And last but not least, we have our final warning, which says home search not done. This is our final step. It is step number 5 in order to turn the machine on safely. We need to send all of our axes. So on one of these mills, we have 3, we have an X, we have a Y, and a Z. We need to send them all to the home position. The home position is how the machine recognizes where all of our fixtures as well as all of our tool change positions are coming from. So the very first thing it wants to do is be sent home, and then we can move our axes anywhere we want. In order to send our machine home, we press our 0 button. And when I say 0, I don't mean the number 0. I mean where it physically says 0, and there is a datum location symbol on the actual button. We want to press that 1 time. And the reason we only want to press it once is because when we press it, we have multiple options that we can do within this button menu. So very first, it says for home search, we press start. If we want to exit out of this, we can press escape, or if we want to go to our 0 offset table, we would press this 0 button again. Because we want to 0 return our machine, we want to press our cycle start button. Our cycle start button is over here in the far right hand corner, and when I press that, the machine will automatically begin moving to its home position. So right now my Z axis is coming up, and when my Z axis moves to the 0 position, my table will begin moving the X and Y axis to my home 0 position. You can tell that we are in our home 0 position because when we look on our NC controller, you can see our home Z is at 0. Our home Y is at 0, and our home X is at 0. These little numbers indicate our position in regards to the home or the machine home position. So now that we have safely turned on our CNC machine, we have the ability to either run our programs, or we can set up a new job, we can move our table. Basically, we have full access to this machine because it is up and running in the proper, correct manner. At the end of the class, we're going to need to safely shut down the CNC machine. In order to do that, the very first thing I want you to do is move the table to a center location. So we want to bring the x-axis so our vise is roughly in the middle between our doors. We want to take our y-axis, we want to move it more to the center of the machine, and we want to bring our z-axis and drop it down. Not too far, but just so that everything is off the limit switches. The reason we want to do this is because if we turn the machine off, when our table and our spindle are at the machine home position, they're up against limit switches, which can slowly lose the resistance and feel, and then it causes some issues with the contacts. So it's a lot nicer to move everything off and away, and that way when we do zero return our machine at the very beginning, we can see all of our axes moving to that home position correctly. After we have moved everything to a safe location, it is okay to leave the doors open. We're going to be rinsing these machines out with coolant. This kind of lets them dry a little bit nicer, as well as the next class that's coming in. It's easier for them to do their safety and circle check if the doors are open. So when the machine and the table is in a good location, the first thing we want to do is we want to hit our E-stop or our emergency stop. You'll know we've activated correctly because we have our red alarm bar off across the center of our screen. And the reason we want to do that is because our spindle is fairly heavy. It is resting solely on a ball screw. When we hit that emergency stop, it activates brakes, which lock this onto the axis and takes some of the pressure off of that ball screw. As soon as we hit the emergency stop, our servos also turn off. So we will not be able, or we don't need to turn our servos off for this because the emergency stop will do that for us. The reason we need to move the table to a safe location before we hit the emergency stop is now nothing will move when the emergency stop is activated. It kills all the hydraulics and any function we have to the machine. If we wanted to get out of this emergency stop, we would have to reboot the machine just like we would when we first turned the machine on. So now that we have hit the emergency stop, we can go around to the back of the machine and just turn our main power off.